Okay, so the last part of this section is looking at antiderivatives of different trig functions that we couldn't deal with before. And I alluded to this in our notes on section 5.1 about how we're now going to be able to find the antiderivative of tangent x. In order to do this, we're going to rewrite tangent x as the sine of x over the cosine of x. Okay? And then we need to use u substitution to rewrite this. U is going to be equal to the denominator. And the reason why is because when we find du, it's always a function times dx. And the thing that's being multiplied by dx is really the thing in the numerator. So when we're doing these trig problems, we're always going to use u as the denominator. So u is equal to the cosine of x. The derivative of that is negative sine x dx. I don't have negative sine x dx, so I'm going to bring the negative over with the du and make this positive sine x dx. And then the negative du will replace the sine x dx. And then the cosine x in the denominator becomes a u. So the rewrite of this integral is going to be negative antiderivative of 1 over u du. Which at this point, we hopefully all know that the antiderivative of 1 over u is going to be the natural log of the absolute value of u. So negative ln absolute value of u plus c. We have to replace the u with the cosine x, and then we will be done. Negative natural log absolute value of cosine x plus c. So from here on out, we're going to have a rule that says the antiderivative of tangent x is equal to the negative natural log of cosine x, with the absolute value on the cosine x. If you have trouble memorizing the rule, this is the process that you would go through to do in order to find the antiderivative. So work on memorizing this, but again, you have a backup plan as shown here on how to find the antiderivative. However, we can use a similar process to do the other trig functions that we don't know the antiderivatives of yet. So I'm not going to write out that process for every single one. I'm just going to tell you what the final rules are. So these are the new trig rules, and again, they were found using the same process. We just did the tangent of x. I'm just going to rewrite it here for you. This is negative natural log absolute value of cosine x plus c. So that's tangent. Cotangent will be fairly similar. Cotangent comes out to positive natural log absolute value of sine x plus c. Right? This one ends up being positive because the u was sine x and the derivative of that was a positive cosine x, which would have showed up because cotangent is written as cosine over sine. All right. Secant is a funky one. This is one that you're definitely going to want to memorize and not going to want to try to derive on your own. So this is positive natural log of the absolute value of secant x plus tangent x plus c. Okay? So again, you're better off trying to memorize that than you are trying to derive it. Cosecant will be very similar, except it'll be negative natural log. And then instead of secant and tangent, it's cosecant and cotangent. Cosecant x plus cotangent x plus c. Okay? So we can add these to our list of rules that we need to work on memorizing. All right. So we're going to take a look at two final examples on how to use these rules when it's not just a secant x or a cotangent x. Maybe there's a function on the inside. How do we deal with that? All right. So problem number 9 is to find the antiderivative of secant of 8x dx. The easiest way to go about doing this is to, again, use u substitution. We're going to use u is the 8x because that's what's inside of the trig function. We know, or at least now we know, what the antiderivative of secant is. So if I convert this to secant u, I can use the rule. So this is going to be du is equal to 8 dx. So 1/8 of du is equal to dx. So when I go to rewrite the function, I'm going to have a 1/8 and a du, and instead of secant of 8x, I'm going to have the secant of u. Okay. So the antiderivative of secant u has a natural log in it. So this becomes 1/8 times the natural log of the absolute value. Secant x became secant x plus tangent x inside, so this is going to be secant u plus tangent u. And then don't forget the plus c at the end because this is an indefinite integral. And now I just need to go back and replace the u with an 8x. So our final answer for this problem will be 1/8 natural log the absolute value of secant 8x plus tangent of 8x plus c. Okay. So it's very similar to some of the trig substitution problems we've done before. It's just now the antiderivative has a natural log involved. Okay. Last problem. Number 10. We want to find the antiderivative of x cotangent of x squared plus 4 dx. And very similar to the problem that we just did, we're going to go with u is the x squared plus 4 because that's what's contained inside of the trig function. All right. So I'm going to again do u is equal to the inside of the trig, in this case x squared plus 4. Du works out to be 2x dx. But I don't have a 2x dx, I only have a 1x dx, so I'm going to make that 1/2 of du is equal to x dx. All right. So the rewrite for this guy, we'll have a 1/2 and a du. The x and the dx are now gone, and I'm going to be left with cotangent of u. So the rule for cotangent comes out to be, we keep the 1/2, antiderivative of cotangent is natural log absolute value of sine u plus c. And now all we need to do is replace the u with the x squared plus 4, and we will be done. So this is 1/2 natural log absolute value sine of x squared plus 4 plus c. And that's it.